Hello everyone. Today we will discuss on gas power cycle, and in gas power cycle we discuss on air standard cycles. These air standard cycles are basically used for the heat engines, and IC engine is a type of heat engine. So let's see how these air standard cycles are used for the IC engines. So before that we discuss what is this air standard cycles and why it is used for this IC engines. So IC engine in which the combustion of fuel occurs in the engine cylinder itself are non-cyclic heat engines. So remember, this is a non-cyclic heat engines because in case of IC engine, when mass will enter to the engine cylinder, there are number of strokes like suction stroke, compression stroke, power strokes, and then exhaust strokes. So this is for the 4-stroke IC engine. So in 4-stroke IC engine, during the exhaust stroke, what happens to the mass? That mass will thrown out to the surrounding. So then again during suction stroke, the new mass will enter to the cylinder. So this is a non-cyclic process. If instead of throwing out of the mass during the exhaust stroke that will be utilized for suction stroke, then we can say that is the cyclic case. But as the mass which is entered during the suction stroke and after performing work, that mass will thrown out to the surrounding during exhaust stroke. So that's why this IC engine is considered to be non-cyclic heat engine. The temperature due to the evolution of heat because of combustion of fuel inside the cylinder is so high that the cylinder is cooled by water circulation around it to avoid rapid deterioration. The working fluid, the fuel-air mixture undergoes permanent chemical change due to combustion, and the products of combustion after doing work are thrown out of the engine and a fresh charge is taken. So that's I have discussed that is a minute before. So the working fluid does not undergo a complete thermodynamic cycle. That's why this IC engine is known as non-cyclic heat engine. The air standard cycles are adopted to simplify the analysis of IC engine. In an air standard cycle, a certain mass of air operates in a complete thermodynamic cycle where heat is added and rejected with external heat reservoirs, and all the processes in the cycle are reversible. So see some of the examples of air standard cycle which we discuss one by one in the later case. So the first example is the Otto cycle, diesel cycle, dual cycle and Brayton cycle. We all discuss one by one in the later video. So see, this is the IC engine or the schematic diagram of an IC engine. So this is the cylinder, this is the piston which is moving from TDC to BDC during suction, compression, power and exhaust stroke. And see, when this piston lies here, so some volume is left here, that is the clearance volume. This is the cylinder wall, this is the piston, this is the connecting rod. This connecting rod is, this is the crank mechanism, and this is the valve, inlet valve and outlet valve. This is the spark plug or fuel injector. If it is a petrol engine, so you can say it is a spark plug. If it is the diesel engine, that we can say it is the fuel injector, right? So here one important term which we have to use while we discuss about Otto cycle, diesel cycle, dual cycle, Brayton cycle, that is compression ratio and mean effective pressure. So here we discuss today that is what is compression ratio and what is mean effective pressure. So compression ratio is defined as the ratio of maximum volume formed in the cylinder to the minimum volume. So what is this minimum volume and what is this maximum volume? So see, when piston is moving from TDC to VDC, so the volume is generated, so the maximum volume generated, so that is maximum volume, or you can say volume of BDC. See, here it is written, then minimum volume when piston lies at the TDC, the volume is very small, so that is the minimum volume in the cylinder. So, or you can say that is the clearance volume. See, it is written here, it is defined as the ratio of maximum volume formed in the cylinder to the minimum volume, that is clearance volume. So, this compression ratio is denoted as RK, RK equal to V maximum by V minimum equal to V BDC by V TDC. Next is mean effective pressure. It is the fixed pressure that, if it is acted on the piston during the power stroke, would produce the same amount of net work as that produced during the actual cycle. So, or you can say it is defined as the ratio of net work done by displacement volume. So, displacement volume is what? That is the V maximum minus V minimum. So, what is this V maximum and what is this V minimum? V maximum already we discussed in the previous heading, that is compression ratio, that V maximum is the maximum volume formed in the cylinder while piston is moving from, that is TDC to BDC. And important point is that this mean effective pressure can be used as a parameter to compare the performance of reciprocating engines of equal size. So see, if we compare one engine with another engine and the performance is compared, so both the reciprocating engines must have equal size, and the engine with larger value of mean effective pressure will deliver more net work per cycle, and thus you can say that engine having larger value of mean effective pressure will perform better. Thank you.